Hello, this is my my chapter exam, and we're going to be doing problem 31.7. So, okay, I'm going to start off with part A. In an operation, an electric toaster has an RMS current of 3.95 when plugged into a wall socket with RMS voltage 1.20 times 10 to the second V. Find the toaster's average power. Okay, so first what we're going to do is we're going to list out our values. So V equals 1.20 times 10 to the 2, and then they said I equals 3.95A, right? So then we have to find PAV. So how we're going to solve that is, or how we're going to find PAV is we use equation 31 we use equation 31.31 in section 31.4. So that would be, the equation for that is PAV equals VI, right? So then what we do is we basically just plug everything in. So we know that PAV equals 1.20 times 10 to the second power times 3.95 equals 474 watts. And that is your answer for part A. That's your answer for part A. And also this was an example 31.6 in section 31.4. Now we read for part B. Find the toaster's maximum instantaneous power. So find the toaster's maximum instantaneous power, we're going to use, here we're going to write down as part B. We're going to use equation 31.27 in section 31.4. And also this was also an example 31.6 too. So this would be P max equals VI equals 2 PAV, right? Now we already know what PAV is because we solved in part A. So all we have to do is 2 times 474, which is this right here, and that will be 948 watts for your answer for part B. Now we have to find the toaster's resistance. And in order to do that, we're going to use Ohm's law, spelled AW, and it is written as R equals V over I RMS. And this was an example, I believe, 31.7 in section 31.4. And basically for this is we're just going to plug everything in. So we know that I equals 1.20 times 10 to the second. And then we know that the bottom half, no, that was V, my bad. This is V. You know, the bottom half is 3.95. So we're going to do I'll just put it like this. And then that will equal 30.4. And that is your answer for part C. That was your answer for part C. So basically, you take these two and you divide it, and then you'll get the answer. And then now for part D, an LRC series circuit has a source with voltage amplitude 35 V and angular velocity 1.30 times 10 to the 10 to the cube. The resistance is 275. The inductance is 82.3, and the capacitance is 1.10. Find the inductive and capacitive reactance. Okay, so we're gonna put part D. So basically what we're gonna do is first we're just gonna label out our values just to make everything simpler. So we know VO equals V, we know W equals 1.30 times 10 to the 3, we know R equals 200 and according to the problem 275. And then we know C equals, which is the capacitance, is 1.110. I write the symbol for that. And then we know the inductance is L equals 82.3 M to the H. So what we're going to use is we're going to use equation 31.12 in section 31.2. And basically we just plug it all in for that equation. So how that would look like, it would be 1.30 times 10 to to the cube times 82.3 times 10 to the negative 3, which will equal 107, right? And then our next equation we're going to use is 31.18, which is also in the same section, 31.2. And then that would, and then for that one, we just plug it in. So we have 1 over 1.30 times 10 to the 3 times 1.10 times 10 to the negative 6. And this will equal 699. And this is how you get both of your answers for XL and XC. And that is your answer for part D. Now for A, B, C, D, E, part E. So you can see that. Now for part E, we have to find the phase angle. So in order to find the phase angle, we use the equation in section 31.3, which is, it's like this. So it will be angle equals tan minus XL minus XC over R. Now mind you, we just solved for XL and XC, and I think R was 275. So yeah, so basically all we're doing is just plugging it in. So tan negative 1, 107 minus 699 over 275, and that should equal negative 65.1 degrees. And that is your answer for part E. Now let's flip the page. That's your answer for part E. Now for part F, now we have to find the power factor. So part F, power factor. Okay, so to find the power factor, what we're going to use is we're going to use the equation PF equals cosine well, the angle. And this was in 31.4. And now this part right here, this is the phase angle. Like this part of the equation is the phase angle, and we're going to plug in for this one right here. So we already know what the phase angle, because we just did it in part I think it was part E. Yeah, it was negative 65.1. So all we're doing is PF equals cosine negative 65.1, and then that should give us our answer, which will be 0.421, and that is your answer for part F. So basically, we used the equation from 31.4, and we plugged in for the phase angle, which is this is the phase angle, and we solved for the phase angle already. So we basically just plug it in and solving, and that is how you got part F. Now, let's go to I believe it was part G. So for the circuit in the preceding problem, 31.7.2, find the impedance. Impedance. Okay. So, find the impedance. Impedance. Okay. So it says 31.7.2, and I'm just trying to read it out to you just to so can make it more clear for you to read. I mean for you to grade. So 31. So find the impedance. I'm going to find that for you. It's the impedance. So it was 31.7, 31.7, 31.7, 31.7. I'm just trying to find it real quick. 31.72, 31.72. I'm almost there. Apologize for this. 31.72. Okay. Okay. So the reason why it's taking me so long is because this one, it didn't have a problem for me to read out to you. So I'm trying to find the problem so I can read it out to you. So yeah. Um, so yeah, that's my bad. I apologize for that. Okay, found it. So an LRC series circuit has a source with a voltage amplitude of 35 V in an angular frequency of 1.30 times 10 to the 3 radians over seconds. The resistance is 275. The inductance is 82.3. Oh, okay. So that's my bad. I was so confused. So we're still on part D. We're still looking at part D, and we're still solving for part D. That's my bad. So okay, so for the circuit in the preceding problem, which was part D, find the impedance. So we're going to find the impedance. That's my bad. Okay. So okay, yeah. So part G. Okay, so to find the impedance, we're going to use the equation 31.23, and that is also in 31.4, I believe. So that's going to be Z equals R squared plus XC minus XC over 2. No, XL, my bad. XL over 2. So then what we do is we just plug in our values. So Z equals 275, because we have 275 in part D was R, plus, and then we know that XL was 107. Let me just double check real quick. Yep, XL was 107. So 107 minus 699, which was XC, and then we square it, and then we should get our answer Z equals 653, and that is your answer for part G. So we used equation 31.23, and we're still pulling from part D. That's what I got confused on, but we're still pulling from part D, and we're just plugging into equation 31.23, and then that is your answer for part G. Now for part H, same thing. We're still pulling from part D. Now for part H, for the circuit in the preceding problem, find the current amplitude. So we're going to try to find the current amplitude. So this is part H. So what we're going to use is we're going to use equation. This is how the equation is. This equation is I equals V over Z. Well, I underscore 0, V underscore 0. And this was an example of 31.4 in section 31.3. So then now, since this is the equation we're going to be using, all we have to do is plug in. So we know that V is 35, right? And then we know that Z is what we just solved for part G. So that'll be 653. And then solving this, we'll get, here, I'll just put this in my calculator just to make sure. 35 divided by 653. Yep, we get 53.6 MA for our answer. All right. Now for part I. We have to find the circuit in the preceding problem. So we have to find the average power delivered to the resistor. Okay. So basically to find the average power delivered to the resistor, we're going to use the equation 31.31 in section 31.4. And basically for that equation, it's going to be written as, here, I'm just going to put this part I, and this is going to be written as 1/2 VO LO cosine, and then the phase angle, I believe. Yeah, it's the phase angle. So then all we have to do is we just have to plug in, and yeah, we just have to plug in for this one right here. So 1/2 is 0.5 times 35 times 0.0563, or I could just say times 53.6 times 0.421, and then this should equal 0.395 W. And that is your answer for part I. So we just used equation 31.31 in section 31.4. And that is how we got our answer. And also this was in this equation was in 31.7. Okay, so we are on part J. So the power factor of an LRC series circuit is 0.800. The angular frequency is 1.30 times 10 to the 4. The inductance is 7.50, and the capacitance is 0.440. Find the inductive and the capacitive reactance. Okay, so first, this is part J. First, what I'm going to do is I'm just going to list my values out. So we know that the power, I'm going to put power factor as PF equals 0.800 as listed in the problem. And we know that W equals 1.30 times 10 to the 4th, right? And then we know that L equals 7.50 mH, and then we know that C equals 0.440. So then what we're going to use is we're going to use equation 31.12 and section 31.2. And that is XL, lowercase l, equals WL. So what we do is we're just going to plug it in. So we know what W is 1.30 times 10 to the 4 times, and we know what L is because we just listed it, so it's 7.50 times 10 to the negative 3, and then that will give us part of our answer, which is 97.5. So I'll just go ahead and circle this right here. And then now for the second part, we're going to use equation 31.18 in the same exact section, which was, I believe it was 31.2. So then that would be XC equals 1 over WC, lowercase c. So now we plug it in. So we know, well, the numerator is 1, and then we know the denominator is 1.30 times 10 to the 4 times 0.440 times 10 to the negative 6. And then what we can do is we solve that, and then we get our answer 175, and that is both of your answers for part J. Now we're on to part K. We have to find the phase angle, and I think I did this before in one of the earlier parts. So for part K, phase angle, we use the equation 31.3, and how it's written is cosine and then the phase angle, right? So we know that the phase angle equals 0.800, right? So what we can do is we do cosine -1, and then plug it in for the phase angle right here, and then solving this, we should get, here, just put in my calculator, and then 0.800, we should get 36.87 if you round it. So 36.87, and that is your answer for part K. Now for the last part, part L, we have to find the resistance. Okay, so in order to do that, right? So in order to find the resistance, so what we're going to do is we're going to use this equation right here. So the equation is R equals XL minus XC, and then underneath it is tangent theta. Now this equation was in figure 31.13. So this equation here is in figure 31.13. So what we're gonna do is we're just gonna plug it in. So here, I can do it a little bit on the side. So what we're gonna do is we're gonna do 97.5 minus 175 over 0.75, because the tangent of 36.87 in part K, so tan 36.87, that is 0.75. So this goes over here as our denominator. So solving that, we will get our answer R equals 103, and that is your answer for part L. And that is it for my exam. And I referenced the equations, I referenced the book and the examples, and yeah, thank you.